I will discuss about the arc welding, and end of this lecture the student will able to learn basic principles of the arc welding, voltage, current, characteristics curves of the power source. Another is problems on voltage and current, characteristics, duty cycle, AW, manual metal arc welding, submerged arc welding, tungsten inert gas welding and metal inert gas welding. In case of what is arc welding, means a fusion welding process, means it will create the arc, and due to creation of the arc it will melt the parent metal, means that is the fusion welding process in which coalescence, means joining of that particular metals is achieved by the heat from an electric arc between, due to generation of the arc between the electrode and work. Okay, then energy from the arc produces temperature due to creation of the arc between work metal and electrode. Near about temperature is 5500 degrees centigrade. Okay, and that is enough to melt the metal. Another, most arc welding process add filler material to increase the volume and strength of the weld joint, and also most of the arc welding process helps to melt the metal and increase also volume and strength of that particular welding joint also. What is electric arc? Electric arc means discharge of the electric current across a gap in a circuit, means electric arc means that is the discharge of the electric current discharge between a particular gap. Okay, actually that is the sustained by the, actually it is a ionized column. Ionized column due to, actually ionized column of the gas means ionized column of the air between electrode and metal. Okay, and through which current will be flow. To initiate the arc in arc welding process, electrode is brought into to the workpiece. Okay, then that will be create and separate from the by a short distance, and we brought the electrode to the working metal, and we take some particular distance, very short distance from the working metal, and between that two short distance, if we are consider that is the metal plate, and we kept the welding torch, that is the very short distance, that is the very short distance, and between that short distance what happens, the arc will be created, means plasma ionized column will be created through that gap. Through that gap ionized column will be created of the air. Two basic methods of the arc welding. What are the basic methods? First is consumable. Consumable means here consumed during welding process. Consumed during welding process. Another, filler metal. Here also we have used the source of filler metal. Filler metal we have used in that consumable as a consumable of electrodes. Okay, and consumed during welding process. Here filler metal will be consumed during welding time. Okay, in case of non-consumable, here not consumed during welding process. And also filler metal may be used or may not be used. Sometimes as per requirement we use some filler metal separately. Here if we are using the filler materials in case of non-consumable, so at that time we use the filler material separately if it is required. Arc shielding. In case of arc shielding, we have shown that now metal sometimes during melting time, parent metal, sometimes it is chemically reactive, okay, with the oxygen. So due to that thing we use some flux, and due to that reactions with the chemical, sometimes oxide will be created, and due to creation of the oxygen, the quality of the weld surface that will be degraded, and from avoiding that things we have used some air shielding gases. What are the air shielding gases? argon, helium, CO2 and also flux we have used for shielding purpose. What are the main function of the flux? Flux material used for protecting the formation of the oxides, and that oxides also deteriorates the quality of the weld surface. That's why we use the flux material. Okay, and sometimes that flux materials also dissolve with that molten metal. Sometimes we using some chipping hammer, we remove that weld, extra oxide materials, and that flux material, what the purpose of that things, it will protective atmosphere. Means what is the function of the flux material? It will protect the weld surface from the oxygen. Another, stabilize the arc also, and also it will create the stabilized arc between the work surface and the electrode. Another, it reduces spattering. Sometimes due to spattering during welding time, sometimes extra metals will be accumulated during weld surface. So avoiding these things using also fluxes. Due to using of flux, we avoid that things also. What are the various application methods? First one, we use the granular flux. Also we use on the welding operation. Using that granular flux also we creates the stabilized arc and also removes the oxygen, means we remove the oxide formations from the weld surface. Another, also we use the stick electrode coated with flux material. Sometimes we use the some filler material, or and also we use some electrode with some using some coating, and due to that thing, sometimes with that particular filler material and also electrode material does not react with the oxygen. Means that protecting things helps to protect with the reaction with the oxygens also. Okay, and another, sometimes we use the tubular electrodes. Means that in that things contained in the core and released as electrode is consumed. Means some in case of tubular electrodes is in which flux is contained, means that particular electrode's flux will be remained. Okay, and due to containing of the flux in that particular tubular electrodes, it will melted during welding time, and due to melting of that particular weld materials, means filler material, it will also create some protective layer on that weld face, and due to creating weld protecting layer on the weld face, it removes the oxide formation, means it will act as a deoxidizing reagent. Another, some power source. What type of power source we have used in case of arc welding? First, direct current source also we have used. Also we have used the alternating current. So AC machines is the less expensive to purchase in our market, but it has some restrictions. Means that AC machines we have used only in case of ferrous materials. In case of ferrous materials we have used the AC machines. Alternative current source we have used. In case of direct current source equipment, it will be used all metals, and also it will be used any type of ferrous materials, also used in any type of non-ferrous materials also. And also this direct source helps also to control the arc generation between electrode and workpiece also. Direct current. In case of, what is the meaning by direct current? So in case of conventional theory, we know the positive terminal to the negative terminal as per our conventional theory. Means higher potential terminal to the negative terminal, means current will be flow from positive terminal to the negative terminal. Means higher potential terminal to lower potential. Another is in case of electronic theory, the current will flow negative terminal to positive terminal as per electronic theory. As per conventional theory, current will be flow from higher potential to lower potential. In case of latest machine, some polarity also we have added. Means it will easily change the polarity during welding time. What are the kinds of polarity? First one we have used state polarity or we have used the reverse polarity, means direct current state polarity. In case of state polarity, what we have done, now workpiece will be connected to the workpiece. Here we have seen that is the workpiece, workpiece will be connected to the positive end, means positive terminal, okay, of the power supply. And in case of electrode, that electrode will be connected to the negative terminal of the DC power source or AC power source in case of state polarity. Another reverse polarity, in case of reverse polarity we have done just vice versa of the state polarity. Here electrode will be connected to the positive power supply and workpiece will be connected to the negative power supply. But which is better? In case of welding, the state polarity is more better. And here what happens? Now more penetration depth also possible and also quality of the weld face, it is also very good using state polarity. In case of direct current state polarity, the accumulation of the weld metal as like that things, means that is the generation of the arc, means if that is the electrode and that is the workpiece, okay, that is the workpiece, means between that workpiece and electrode, that is the created arc, means ionized plasma, means ionized column of the air or gas, okay, and the shape of the created weld face as like that, means more penetration depth will be created in case of state polarity. And in case of direct current reverse polarity, what happens, that is the weld face, and that is the created arc between the workpiece, and that is the electrode, okay, that is the weld face, means here penetration depth is less in case of direct current reverse polarity. And in case of AC current, we have seen that here with respect to direct current reverse polarity, the penetration depth is higher, and that is the shape of the weld face, and that is the generation of the arc. What are the applications of the polarity? So here we seen that in case of state polarity, we have known that the negative terminal will be connected to the electrode and workpiece will be connected to the positive terminal. So here welding with bare light coated and medium coated electrodes we have used in case of state polarity, okay, and here penetration depth also higher, means that state polarity will be used in case of thicker sections, and in case of reverse polarity generally used for non-ferrous materials, okay, and also it will be used for cast irons also, okay. Heavy, that also welding with heavy and super heavy coated electrodes also we have used in case of reverse polarity, and also the penetration depth is also less in case of reverse polarity. It will be used in case of sheet metal welding, and also it will be used for positional welding also. What are the conjugate electrodes? In using conjugate electrodes, what are the types of the arc welding process? First one, shielded arc welding, means SMAW. Then gas metal arc welding, GMAW. Another is flux coat arc welding, that is the FCAW. Okay. Then electro gas welding. Last one is submerged arc welding. So, what are the arc welding? In case of arc welding, here it is a fusion welding process. It creates it melts the parent metals using arc. Due to melting of the parent metal, the molten metal, means melting takes place to that particular metal, and using that melting metal the welding has been done, and due to creation of the arc more heat will be generated to that weld surface, means to the parent metal, and due to that thing the metal will be melted. The welder creates an arc that melts the base metal and filler metal. Sometimes we have used the consumable metal, means filler rod we have used for welding purpose also, and due to fuse of the base metal and filler rod we join the both surfaces. In case of arc welding, we use in case of pipelines that bring fresh water, and also we have used the towers for welding purpose. Okay, another is cars, buses. In that cases for welding purpose we use the arc welding. Arc welding extensively we have used the constructions of the steel structures in industrial fabrications also. Another, the process primarily used to weld the iron, steels, for aluminium, nickel, copper alloy. So in that cases for welding purpose also we use the arc welding. Another, the welding, other welding process maintenance and also repairing industry, also we have used the flux core arc welding process also. Okay. And it is popular. Why it is popular? Now, because that field means that welding process is a simple and portable process without using the complicated equipments. In case of manual arc welding, here why it is called manual arc welding? Now here we do the welding using manually, means here welding torch we kept, just one man kept the welding torch, and using that man he do the welding operations as per our requirement fabrication industries, means that done as manually. And also sometimes we use some conjugal electrode coated with flux. Sometimes we use the conjugal electrode, means filler rod we have used, and in that filler rod some particular coating is there, and due to use that coating, so it will avoid the oxidation. And also sometimes the filler rod will be coated with flux also. At that flux during welding time it will also melted, and it will also created some slack layer, and that slack layer removes, that slack layer protects the formation of the oxides. And electric current in the form of alternating current or directive current, that will be we are getting from the welding power supply, and that will be, that helps to create the arc between workpiece and the electrode, and also it will create the melting to the parent metal, and also it will melt the filler metal. It will help to join both the surfaces. Sometimes we are using some due to flux coating electrode disintegrates and giving a vapors. Sometimes due to heating and melting of that particular electrode, sometimes vapors will be created. That vapors creates the shielding in that particular welding surface. That also helps to protect from the oxide formations to that particular weld surface. In case of arc welding, what we have seen, that is the welding torch, and that is the electrode wire, and that is the electrode coating, to that particular electric wire. Okay, and after that is the welding torch, and that is the main base metal, and when we say, provide the power supply, that type of arc will be created. Between that electrode wire and base metals. Okay, and actually that is the ionized column of the gas or air. Okay, that are the metal droplets. Okay, and that is the base metal. After using that particular torch, here the metal will be melted. Okay, and after melting, both the metals will be joined, and after melting sometimes it will be solidified weld metal, that is the solidified weld metal. And when flux or coating will be melted, that type of slag will be created. On that weld surface, and due to creation of the slag, it will protect the weld surface also, protective gas from the electrode coating, and due to creation of the weld electrode coating, that will be helps to protect the weld surface. And that are the molten metal created due to using that torch, means electrode wire. Due to that using electrode wire, it will create the arc, and also it will melted the metals also. arc welding, also sometimes it is known as a stick welding. Okay, uses arc between the covered electrode and workpiece. Shielding sometimes obtained from the electrode cover. Sometimes shielding gases we have got from the decomposition of the electrode cover. And pressure also not required. Here we have not used any pressure, and also filler material sometimes also we have used as per our requirement. What is the principle of the arc? A suitable gap will be maintained between the work and the metal. Then a lighter current, means we provide the power supply from the particular welding power supply devices or welding power system to that particular circuit. Then the electric energy will be converted into heat energy. Then electric energy will be converted into heat energy, and it will create it near about 3000 to 4000 degree centigrade. Okay, this heat melts the edge to the across the weld faces, and then molten pool will be formed, and solidification of the welding joint is obtained to across the particular weld surface. What are the process? Means intense heat will be generated at the tip of the electrode, because we providing the electric current, and due to flow of the electric current, tip of the electrode more heat will be generated, near about 3000 to 4000 degrees centigrade will be created, and due to creation of that heat, when we keep the electrode near the metal surface, then one ionized column will be created. That ionized column will be created, means arc will be created between that two electrodes, means between metal workpiece and electrodes, and due to creation of that things, the arc will be created, and due to creation of the arc, it will melt the metal. Okay, and then the weld solidified surface we have got. A molten metal is deposited. A slag forms over the bead which serves as a, sometimes due to melting of the flux to that particular means flux core, means to the particular filler material, flux coated is there, and during melting of that particular filler material, flux also melted, and after welding, the flux coated layer will be formed on that particular welding surface. After a weld pass, it is allowed to cool, and the oxide layer is removed by the, sometimes oxide layer also formed, that will be removed by the chipping of the hammer, and then cleaned with the white brass. Sometimes also using white brass, we clean the also oxide layer also. In case of arc welding, we have seen that we are taken that two parts we want to be melted, okay, in view, and here we have seen that is the electrode, that is the main electrode, and here we have used the filler material. Sometimes filler material also coated with using some flux coating, also electrode sometimes also coated with some flux coating, okay, and that is the base metal, and due to melting of that particular flux material, that also created some oxide some slag layer, also slag layer also created here. That slag layer or that slag skin also protect from the oxide formations also, and that is the melting zone, and that is the arc created between the electrode, and that is the base metal. Okay, and that is the filler material, and that is the molten metal, and that molten metal after sometimes it will be solidified, and solidified weld surface will be created in that particular zone also. Okay, and after welding, that type of welding joint will be created. Actually, that is the penetration depth, that is called penetration depth, that is called penetration. Okay, that is the end view, and that is the cross section view during welding time. And actually that is the bare electrode, that are the bare filler material also we have used, and we have used the electrode coated, that is the electrode core wire, and sometimes that type of shielded, means that type of shielded heavy coating also we have provided that particular core wire. Okay, and due to when that core wire melted, sometimes due to melting of that heavy coating, some protective gas or vapors will be created, and due to creation of that vapors, that type of protection layer, will be created, that type of protection layer will be created across the melting zone. Across the melting zone, the protection layer will be created. That protection layer helps to protect from the formation of the oxides to that particular weld zone. That is the slag layer. That is the slag skin. That is the slag skin, and that is the weld, solidified weld surface. Solidified weld surface. Solidified weld surface. And that is the base metal, and that is the weld deposited, and here molten metal will be created, and that is the penetration depth. That is the penetration depth. What are the basic steps? First we prepare the base materials. We prepare the base material we want to weld. Means from that particular base material we remove the paint and rust. Okay. Then choose the right welding process. If we are taking leftward welding or rightward welding process. Okay. Then choose the right filler material. Means particular parent material, which filler material is required, which filler material is appropriate. On that basis we have choose the filler material. Then assess and comply with the safety requirements, and during welding time also we are taking some safety precautions also. Also we use the proper welding techniques and sure to protect the molten powder from the contaminants. Also we are taking the particular filler materials with particular flux coating, so it will help to protect from the shielding, to protect from the oxide formations also. And also last one, inspect the weld. So electric power, generally two types, one is AC type power source, another is DC power source. So generally we have preferred that AC power source. In case of AC arc welding, instead of 220 volt and 50 ampere current, for example, the power supplied by the transformer is around 7 to 45 volt and current up to 600 ampere we have used in case of AC arc welding. In case of DC current, we have seen that generally the current range near about 600 amperes, okay, and volts 45 to 95 volts we have used. And in case of DC, can be given into a state polarity and reverse polarity we have provided. The polarity will affect the size and applications. Means as per our requirement, we have used the state polarity and reverse polarity. In latest machine, latent DC power supply also automatically change the state polarity and reverse polarity also. What are the comparison AC and DC arc welding? So in case of direct current from the generator we have got, so in that cases it has less efficiency, okay, power consumption also more, another cost of the equipment also more, low voltage, safer operation, okay, suitable for that DC current, suitable for both ferrous material, non-ferrous materials also, preferred for welding thin sections also, okay, another positive terminal connected to the work and negative terminal connected to the electrode in case of direct current power supply. In case of voltage current characteristics, in that cases we have seen that generally the welding operation, large fluctuations of the current and arc voltage resulting from the mechanism of the metal transfer and other factors. Generally in that cases we have seen three types of characteristics, graph characteristics of the power source. First one, drooping arc voltage, second one is constant arc voltage, and third one is the rising arc voltage, DAV, CAV and RAV. First one, that is the DAV, direct arc voltage. Here we have seen that the current is increasing. After sometimes the current will be increasing, current will be decreases. Means current will be increasing but voltage will be decreases. First one. Second one, we have seen that the current increasing but the change of voltage is constant. And third one, we have seen that current is increasing and after sometimes it will take constant, but after sometimes the voltage will be increasing. Mean in that graph, first graph, in first graph we have seen that In case of first graph, in case of drooping R voltage, here we have seen that particular graph, the current will be increasing, but voltage will be decreasing after some times. Drooping R voltage. Second one, that is called, second one we have seen that is the constant arc voltage. In case of constant arc voltage, here current will be increasing, but voltage will be constant. And rising arc voltage, here we have seen that current will be increasing, after sometimes voltage also increasing. So in case of first one, that voltage current characteristics is preferred for manual sealed metal arc welding. That first voltage current characteristics used for manual sealed metal arc welding. Second one, it will be used for semi-automatic or automatic welding process. Second one means constant arc voltage, that voltage current power source is applicable in case of semi-automatic or automatic welding process. Third one, rising arc voltage, in that cases it will be applicable in case of applied to fully automatic process. That will be applied to fully automatic process. So using that arc voltage, some math is there in case of arc welding. So how we solve that particular math? First one, the DC power source for arc voltage has the characteristics 3V plus I equals to 240, where V equals to voltage, I equals to current in ampere. For maximum arc power at the electrode, voltage should be set at, what will be the voltage? So now first we will take this equation, 3V plus I equals to 240. Okay, then we find out the maximum arc power. How we will be solved? Just we kept the equation 3V plus I equals to 240. Okay, maximum power means we take the first order derivative and second order derivative. So first we find out the maximum power is required. What will be the maximum? We find out the maximum, the voltage. Finally we find out what is voltage. So from that particular equations we write the equation and then we find out the I. What is the I? I equals to 240 minus 3V. Okay, then we know the formula P, power equals to voltage into I. Just using that equations we put the value of I in that particular equations. Means here V equals to V into 240 minus 3V. Then we multiply, finally we have got 240 minus 3V square. In case of for maximum power source, we know first order derivative, means across this equation we do the dP minus dV equals to 0, and we put 240 minus 3V square. Okay, means we put 240 V minus 3V square. Okay, then we do the first order derivative, then 0. We do the first order derivative, means across dP by dV. In case of for maximum power, means here also we have write, means also we can write P equals to 240, or dP by dV also we can write just first order derivative 240 minus 3 into 2 means 6V. Then as per first order derivative we can write 240 minus 6V equals to 0. Then V equals to 240 minus 6 equals to 40 volt. As per questions, the final voltage is 40 volt. Next one, 1 millimeter thick steels are to be spot welded at a particular current around 5000 ampere, assuming effective resistance to be 2 micro ohms and current flow time 0.2 seconds. Heat generated during the process. What will be the heat generated? During welding time, already you have know the particular formula Q equals to I square RT. Using that formula, we will find out the generated heat. Here, I square means 5000 ampere. That is the I. I equals to 5000 ampere. Okay. Then resistance equals to 200 micro ohms. Now we will convert into ohm. Means here we can write 200 into micro ohms means 10 to the power minus 6 into current time T means time, current flow time 0.2. After calculation, what will be the generated heat? Just we put the heat generated formula Q equals to I square RT, 5000 square, 5000 I square means 5000 square. Then R 200 into 10 to the minus 6 and T means 0.2. Finally, we have got the 1000 joule. What will be the duty cycle? Duty cycle means it will describe the amount of time spent during weld metal. Means duty cycle means it will provide the time on that particular time we melt the metal using welding torch. Okay, means describe the amount of time spent depositing the weld metal, depositing the weld metal to that particular weld surface, means that is the arcing period, means as the percentage of the total time taken to complete the weld. Means duty cycle means the amount of time spent depositing weld metal as a percentage of the total time to complete the weld. Okay, so in USA it is duty cycle is called operator factor, and in that some particular duty cycle percentage we are taken in case of workshop welding. In case of welding process, that is the MMA, manual metal arc welding. So here typical duty cycle percentage near about 25% and range 15 to 40%. In case of MIG, metal inert gas welding, or metal arc welding, gas metal arc welding, semi-automatic, near about 40% duty cycle. Okay, typical percentage range varies from 15 to 60%. In case of MAC welding, automatic, here duty cycle 90% and it will vary from 50 to 100%. Flux core arc welding, that is a semi-automatic, here near about typical duty cycle percentage 40% and it will vary from 15 to 55%. So submerged arc welding mechanized, in that cases near about duty cycle percentage is the 40% and it will ranging from 40 to 90%.